Continue. We are now on quarter 1, week 3B. The goal is that for you learners to illustrate rational algebraic expression. So let's start with concepts. It says here in your module 3B, a rational algebraic expression is an expression that can be written in the form P over Q, where P and Q are polynomials. And take note, the Q or the denominator must not be 0. And another one, a polynomial comes from the word poly, which means many, and nomial, which means term. So many terms. A polynomial can have constants, variables, and exponents. For an expression to be a polynomial term, it must contain no square roots, or no cube roots, or no nth roots of variables, no fractional or negative powers on the variables, and no variables in the denominator of any fraction. Okay, let's try example 1. It says here, match it to me. For the directions below are the verbal phrases. Write them in symbols. Choose your answer from the choices inside the box. So let us consider here, number 1, the ratio of a number x and 4 added to 2. So when you say the ratio, it means that x over 4 or x divided by 4 added to 2. And that is number, or I mean letter E. So we have in the solution here, letter E is the answer for the sentence in number 1. The number 2 statement, the product of the square root of 3 and the number y. It is the product of the square root. So we have here letter D as the answer. And for number 3, the square of a added to twice the a. So meaning it is a squared plus a. Twice. So that's 2a. So it's letter C. For number 4, just change this number. Wait, let us try to change the number just for the purpose of discussion. So we have it here. So that we will not be misled. So number 4, this is 5, this is 6, and this is 7. So for number 4, the sum of b and 2 less than the square of b. So meaning less than, no? So b plus 2, that this should be subtracted from the square of b. And the answer is letter A. So for number 4, answer is A. And we have it here. So for number 5, the ratio of the number 3 and the square of C. So it should be in letter B, 5B. Okay, we have here the solution. Then for number 6, the cube root of 9 less than a number W. That means that we have to subtract cube root of 9 from W. So it's W minus the cube root of 9, and that's letter F. And for number 7, the product of Z raised to negative 3 and 2. So that is, for number 7, that's letter G. Okay. Now we have to identify which are polynomials. And for letter B, which are non-polynomials. So take note, letter A is a polynomial. All the exponents of B are positive. Okay. There is no cube root or square root. Then for letter B, is letter B a polynomial or not? Well, b has a negative exponent. So meaning there is no, wait, we have to take note that these 1 to 7 examples consist of polynomials and non-polynomials. In the solution here, we have letters A, C, E, and F are considered to be polynomials. So where are those? Let's encircle those. Letter A, so these are polynomial expression for letter A. This one, letter A, is a polynomial. Letter B is not, because of this expression here. Letter C, it is a polynomial. Letter G, wait, let's go to letter D first. Letter D is none, or it's not a polynomial because of this square root of y here. If it's just a square root of 3, it's okay. Letter E, is letter E a polynomial? Yes. Although there is a fraction here below, but it's a constant. For letter F, it is a polynomial. Why? This is the variable with an exponent positive, which is 1. And this one is a constant, although it contains cube root of 9. It involves 9, cube root of 9, but it's a constant, so it is considered as a polynomial. In here, it's not. Why not? Because there is a variable z with a negative exponent. It's a no-no in the polynomial expression. This could be written also as 2 over z, let me have the z cube. So it's similar to letter B. So they are non-polynomials. Let's move on to page 2. And we have example 2. Compare and contrast. Compare and contrast. Let's make it bigger. Okay. We have to use our answer in example 1 to determine the similarities and differences between polynomials and non-polynomials. So these are the answers that we have in example 1, and these are polynomials. Non-polynomials are those with variables in the denominator with an exponent, or this one, a negative exponent, and then we have a radicand that contains a variable. Now, questions. A. How alike are polynomials and non-polynomials? And for letter B, how different are polynomials from non-polynomials? And letter C, are non-polynomials also rational algebraic expressions? Now we can answer that in here. For letter A, how alike? So how are they similar? Polynomials and non-polynomials. Now, question is, can polynomials and non-polynomials written as an algebraic expressions? Yes, both can be written as an algebraic expressions. Can polynomials and non-polynomials be considered fraction? Yes. And can they be considered as radical expression? It's a yes for a polynomial and a yes for a non-polynomials. What are their differences? For question B, how different are polynomials from non-polynomials? How different? In terms of their exponents, take note, polynomials have positive exponents and whole numbers, meaning it includes 0. Non-polynomials, it has a negative exponents and rational exponents, or when we say rational, it involves fractional exponents. So those are non-polynomials. In terms of the denominator, Polynomials can only contain constants, denominator, or with variables. And non-polynomials, it contains variables in the denominator. Non-polynomials. For the radicand, if it is a polynomial, the radicand, or meaning inside the square root, the cube root, it has to be constants only, not with a variable. And with the non-polynomials, it could include the variables. So those are the differences and the similarities of polynomials and non-polynomials. Now, what about the question, are non-polynomials also rational algebraic expressions? Now, let's try to see. Here, non-polynomials are also considered as rational algebraic expressions because they can be written in the form P over Q, where P and Q are polynomials and Q is non-zero. For example 3, we have here classify me. For the direction, illustrate rational algebraic expressions by writing your answer on the column for rational expressions. So this is just an example. So let's move. So page 3. Okay. To answer questions letter C, the following rational algebraic expressions, these are non-polynomials. Why non-polynomials? Because it has a denominator which is a variable. Okay. Variable with the powers. So these are non-polynomials. But these are rational algebraic expressions. Also with this one. And we have also non-rational algebraic expressions. So you say this, no, they are not. So we have here 5c raised to negative 3. These are not. And these are examples. Well, this choices 2, 4, 6 expressions here. We have to classify whether rational algebraic expressions or non-rational algebraic expressions. There are only 2 non-rational algebraic expressions that contains radicand signs, and the rest are non-polynomials, but they are rational algebraic expressions. Let's move on to exercises 1, 2, and 3. Let's answer this with the following given. There are 4 numbers given. Now in exercise 1, it says here transform the following in symbols. Now we have to transform it. Number 1. For number 1, it says a number h raised to the 4th power. So we just simply write a variable h with an exponent 4. H raised to 4. How about in number 2? 1/3 of the square of c. So we can write it as 1/3 1/3 c squared. Or we can have actually c squared all over 3. There. Then we have the cube root of 9 less than a number w. Well, meaning the cube root of 9 must be subtracted from the number or the letter or the variable w. So we have here cube root. Okay. Then for number 4, the product of p and q divided by 3. So multiply p times q, or just simply write pq all over 3. So we are done with exercise 1. For exercise 2, we determine if the given expression is a polynomial or not. Now, h raised to 4, is it? Yes, because it has a positive exponent. It's a yes. How about number 2? C squared over 3. Take note, in the notes earlier, it involves, in the denominator, it involves variable, but it has to be that the denominator of a polynomial expression must be only a constant. I stand corrected. That's a correction. So is this a polynomial? Yes. It's a yes. 2 yeses. How about here? Although this involves radical, cube root of 9, but this is just a constant, no variable. So this is also a yes. A yes. 3 yeses. How about here? The product of p and q divided by 3. It has a denominator 3, but 3 is a constant. So it is also a polynomial, and it is a yes. 4 yeses. We move on. Exercise 3. Illustrate expressions which are rational algebraic expressions or not. Explain your reasons. Now, we have here, we have to answer exercise 1 before 2 and 2 before 3. So we're done. Why yes? What's the reason? Well, we can have the reason, one of the reasons is that it contains positive exponent. Reason is, yeah, now you can write as it is a rational algebraic expression. Okay. RAE with positive exponent. Bear with me in my writing because I'm still adjusting with electronic pen. Let's have, this is just small letter p. Yes, with positive what? Positive exponent. 4. Okay, let me have it here. 4 is a positive number. Okay, there. Done. Here, it's a fraction. It has of the form p over q. So you can reason out as it's a rational algebraic expression, RAE, of p over q form. There. How about number 3? It's a yes. Why? Well, reason is like number 1. So RAE with positive exponent. Bear with me with my handwriting, please. And how about this? Same as number 2. Okay, we can write same as number 2. It's a shortcut. Now let's move on to the numeracy skills. Sorry for that. Let's see. Let's use the pointer here. Wait. Numeracy skills. Let's continue. 4 divided by 4. Well, of course, it's easy. Any number divided by itself is 1. Now, for number 2, 16 stars divided by 8 stars. So we have 2 And number 3, the ratio of this number of balls, 2 rings of balls, we have to count this, it is 12. Then this is also 12 by 1 set. So 2 sets of 12 by 1 set of 12. So the ratio is 2:1. Wait a minute because we have some corrections here. Let's go back to your module on page 2 in this slide. So please refer to this on the topic, how different are the polynomials and non-polynomials. So under the denominator, we have, for the polynomials, it should be the case that polynomials it will only contain constants, not with variables. Because if with variables, the variables in the denominator has already a negative exponent. So that's it. So please bear in mind, the polynomials has constant denominator. That's all. So do not write anything on the module. Just write this or correct it in your lecture notebook for your personal reference later. Okay? So this is all for now. Thank you, and this is Teacher 𝗲𝗲𝗍𝗲. Keep safe always, and God bless. That ends our Quarter 1, Week 3 B module.